everyone, it's Drew here again, and today we're going to be talking about operators. So what operators allow us to do is to perform different sorts of operations between variables and its values. So there are many different sorts of operations that we can do, and I'm going to go over the different types and give some brief examples for each one. And then at the very end, I'm also going to be including a real life example that will be implementing these operators on a data set. So if you're doing this this Python tutorial, you're most likely going to be using it for either web development or something along the lines of data science or machine learning. So if you stick around to the very end, I will be including something that will be more revolved around the data field. Okay, so with the first operators that we're going to be talking about are arithmetic operators. So they're just basically just math operations. And also too, I'm not sure if I just mentioned it, but I will be including a link in the description below, which will go over all the different sorts of operations. So definitely check that out. Definitely explore them so you can get yourself familiar with them. There's so many different types that if you don't remember all of them, it's not a big deal, but it is very helpful as a programmer to know where everything is at. So it's we're called glorified Googlers, and to a point that's kind of right. So definitely know where to research your things as opposed to just memorizing everything. Okay, so with that being said, the first sign first arithmetic operator we'll be talking about is the division sign. So you see I have two examples right here. So it's just 10 divided by 2, and what this will do is the division sign will result in a floating point number. So if we have two integers, even though these are two integers, we do shift enter, it'll result in a floating point number. So 10 divided by 5, or 10 divided by 2 will equal 5.0. And then if we do 10 divided by 3, we will still get our floating point number. And as you can see, it's 3.333333, and so on. Now if we do floor division, which is the two forward slashes, what floor division will do is it'll actually it'll convert it to an integer, so it'll stay an integer. So 10 divided by 2 is just going to equal 5. It's not going to equal 5.0. So just like you have there. And working with different sorts of data types, you might need an integer, you might need a floating point number. It just depends on the problem you're working with. Okay. But like I said before in the beginning, I am going to be showing you an example at the end. So that was 10 divided by 2 is 5, so 10 divided by 3, so we have up here with the one forward slash, it was a floating point number. So with this, it's just going to equal the integer, so it will not include anything after the decimal point. The next symbol we'll talk about is the modulus symbol. So modulus symbol just it's like finding the remainder. So if you took 10 divided by 2, what would be the remainder of that result? It would be 0, because 10 can be divided by 2 equally 5 times. So that'll be 0. Now, if you had 10 divided by 3, what would be the remainder? What would be the remaining number after that? Which would be 1. Because if you did 10 divided by 3, you can do it 3 times, but that would equal 9, and you would have 1 remainder. So that's where that comes in. And then exponentiation, I always have a hard time saying that, but basically your exponents. So this is your exponent symbol. So if you have these 2 stars, that just means that you're going to take 10 times 10. So you're just going to do 10 times whatever number this is, and or not multiply by this number, but you're going to multiply it by itself this many times. So you have a 10 here, and you're going to multiply 10 times 10. So you're going to do it twice right here, as you can see. So 10 times 10 is going to equal 100. Yeah, so it'll just take this number and multiply it this many times. So those are the arithmetic operators. And like I said, I definitely encourage you to check out the rest of them because there's definitely a lot more. Um, Same with the rest of these different types of operators. I'm not including all of them in there. I'm just including just some of them. So yeah, definitely feel free to check that out. Okay. So the next one is assignment operators, which it's able to do operations between values to variables. So if we have a value of 0 saved to this variable, total team goals, and then we have this right here, this variable goal with a value of 1. One way we could, add a goal to this total team goals is write it out like total team goals equals total team goals plus goal, which would be, since this is 0, this is 1, if you printed this out, well, you know what, I printed that out from before. Yeah. Okay, I accidentally ran that twice from before. So this would equal 1 because you're taking 0 plus 1, and then this now equals 1, and then you're just printing it out here. And if I ran that one more time. So what this is the exact same as this line up here. But you notice I'm writing it twice up here. This you're only writing it once. So instead of saying total team goals equals total team goals plus goal, you can just write down something like total team goals plus equals goal, which is it's literally the exact same thing. And then if you print that out, see, you still get 1. So that's it's like a shorter way of writing your syntax. So it's like very similar to the arithmetic operators, but it's kind of like almost a shorter way of doing it. So those are the assignment operators. Let me go ahead and get out of that. So next we have the comparison operators, which will give us different booleans, or give us any sort of result depending on what we do with it. Like if we put if statements or a for loop in there and we wanted to print out a certain message or have a different condition, we would definitely be using these, which you are going to be using these quite a bit depending on your project, but for this sake, let's just keep it simple. So this symbol right here, all it means is not equal to. So 5 and 5 are clearly the same number, so if you have 5 is not equal to 5, that's going to be false. So you see up here, comparison, it's going to give us a boolean. So 5 is not equal to 5, that would be false. And then but clearly 5 is equal to 5, so that would be true. So just to be clear, when you have one equal sign, that you're just assigning a variable or value to a variable. When you have two equal signs, that essentially means equal to. So 5 is equal to 5, which is true. Our next is our logical operators, which is just to combine different sort of conditional statements. So we have an example right here that if a student had a score of 85, if we did something along the lines of student is greater than 80 and student is less than 90, so this is our operator right here. This is our logical operator. We're using an AND. So if the student has a score greater than 80, but it's less than 90, we're gonna give that student a B. And then you can change this up. You have and, you have or, you have not. So you have the different ones in there. So I keep reiterating. Definitely check out the link below to explore the other operations. But I'm just trying to give you introduced to what you're going to be using a lot when you're doing Python programming. And this goes along the lines of regardless of whatever field you're trying to get into. These different sort of operators you're going to be seeing a lot. So if I print this out, you see it says grade B. So for our identity operators, what we're going to be doing is comparing objects that are the same. So these are our operators right here. Is not. And so it's just, if 3, which is a string, is 3, that's going to be false, because this is a string, this is an integer. And then if we include the identity operator is not, and we have something like string 3 is not integer 3, that's going to be true. And then you have down here, if you have an integer variable and you have it equal to string 3, and you just put the type function around the variable. So if you just did type I, it would equal a string. And if you include the identity operator is not float, you're basically saying this type, the type of this value right here, which is a string, is not a float. And it's not a float, it's a string, so this will be true. So I hope that wasn't too confusing. Next we have membership operators. And what membership operators allow us to do is to see if something else is included within another object, or in this case, in this example, we have a list. So if we had a list of different Avengers of the original 6, and we put the code Xavier in Avengers and we ran that, so this is our membership operator is in, and then we also have not in. And if we ran Xavier in Avengers, you can see Xavier is not in Avengers right here, so this will definitely come out to false, just like that. And then let's run the same thing again, but let's put the not in Avengers. So is Xavier not in Avengers? True. So that gives us some more Boolean outputs based on what is included within an object. And then our last set of operators are the bitwise operators. Now, depending on what you're working on, you might be using these quite a bit, but personally speaking, I rarely ever use these. So, I mean, it might be helpful to know though, which is why I'm showing you in this video. And plus, I just want to get you introduced to them. And there's with every other ones, there's more operators for each of the different sections I showed you. So definitely check out the documentation. So with bitwise operators, you're essentially just comparing numbers from a binary standpoint. So I wrote 14 up here as a binary number. I wrote 3 down here as a binary number. I don't want to go too into detail, but if you're a little unfamiliar with what binary numbers are, essentially they're just ones and zeros that make up these regular integer numbers. So, and then each placement of these, you see how they're separated into 4 groups. So there's four numbers here, and then there's 4 numbers here. The first number will be represented as a 1. The second number will be represented as a 2, then a 4, then an 8. So if you had a 1 in each of these, that would be 8 plus 4, which is 12, and then 12 plus 2, which is 14, and then plus 1, which is 15. So every time you have a 1 there, you basically just kind of add that number to it of what value it represents, and that's what you get. So this is going to represent a 3, this number right here, because you have a 1 in the 1's place, and you have a 1 in the 2's place. So it'll be 2 plus 1 is 3. So if you had a 1 here, it would be 4, because every place that you move up, you just multiply it by 2. So this is 1, this is the 2's place, the 4's place, the 8's place. So if there's a 1 here, those 0, 1, 1, 1, that would be 4 plus 2, which is 6, and then 6 plus 1, which is 7. So that would be a 7. But in this case, we have a 14, which is up here, and the 3. And what this bitwise operator, this little this and symbol right here, will compare each of these numbers. So this 14 and then this 3, and we'll output a 1 if both of these numbers are a 1, and only if both of the numbers are a 1. So you see these are zeros, so these will all be zeros. But then let's move to these set of this segment of numbers. So this is a 1 up here, this is a 0. So I actually write the output down here. So this is a 1, this is a 0, so this will output a 0. This is a 1, this is a 0, output a 0. This is a 1 and this is a 1, so since they're both 1s, then that'll be a 1. And then same over here, this is a 0, this is a 1, so this will be a 0. So because both of these are 1s, that means that this is the only one that's a 1, so this will translate to 2. Because this binary number so it's, remember the placement, 1, 2, 4, 8, 32, 64, 128, 256, all that. So this is the 2's place, and this is the only 1, so it'd be a 2. And then this pipe right here, this pipe symbol is the OR symbol. So instead of doing, if the first number has a 1 and the second one has a 1, I'll put a 1. In this case, we're going to do if the first number has a 1 and the second, or let me back up. If the first number has a 1 or the second number has a 1, include a 1. So you have so these are all zeros, so these I'll put at 0. You see that this is a 1 and that this is a 0. So since it's 1 or, it needs to be, it's an OR case, it needs to be 1 or the other, you can make it a 1. And same with here, so this is since you only need one, you only need a single 1. In this case, I don't want to have to say you need a 1, 1, because that just doesn't sound right. So you need a single 1 in order for this to output a 1. So 1, 0, output 1. 1, 0, output 1. 1, 1, since it's the same thing, as long as one of them is a 0, it'll output a 1. 0, 1, output 1. So if you do 14 or 3, you will get a 15, which is, remember the placement, you got 1, 2, 4, 8, so it's 8 plus 4, which is 12, plus 2, which is 14, plus 1, which is 15. And then down here you have the XOR, which will only output a 1 if, and only if, one of the single ones is a 1. So you'll see here, this is a 1, this is a 0, so this will output a 1. This is a 1, this is a 0, this will output a 1. But now you see that this is a 1 and then this is a 1. So because these are both 1s, that will output a 0. Because with an XOR, only one of them can be a 1. So, and then we move on to this next one. Because only one of them is a 1, you have 0 and a 1, that will output a 1. So with this number, try to guess what this number is before I print it out. Alright, you got your answer? Alright, it was 13. And then so for this last one, this what this symbol means, this will actually it will pivot your number down this many spaces. So it's going to take this number, which I have up here, this is 10 in binary, it's going to take this this number and move it, and move the ones that many places. So you see I have 0, 0, 0, 0, 1, 0, 1, 0. Now, and if you move these over 3 places, 1, 2, 3, then you have 0, 1, 0, 1, and then the rest of these are zeros, which I have down here. So you see that this 1, 0, 1, 0 literally moved 3 positions over. So it's 1, 0, 1, and then the rest of these are zeros, which will equal 80. And then so far, finally, for our last example, I'm going to show you a kind of an example with, that revolves around data analysis and data science. So, kind of give you a real life example of kind of how you can be using these different sorts of operators, okay? And I'm not going to make it too complex, but I do want to show you that this is what you guys are going to be using a lot of the times when doing, any sort of operations, which are very common. So I went ahead and I made a data frame. So first thing you want to do is you want to import pandas to make your data frame. And you see to make a data frame, you just put PD. So you import pandas as PD, and then you put PD.dataframe. And then if you include different list of numbers, I included 3 lists right here, 3 lists of numbers. Those will be all your different instances, so all your different rows. And then if you have columns right here, if you put a comma and then you write columns and you put how many elements you have here. So all of these, so if you have 4 elements in each of these lists, you have to have 4 elements in your column, and then these will be your column names. and I just saved it as DF for data frame. So as you can see here, we have 23, 20, 24, 21, 23, 20, 24, 21. So yeah, 3 lists for 3 different instances. And then these are our column names. So just an example of what we might want to do for a for a different sort of operation example is we might want to add another column here where it takes maybe, like if these were basketball like scores for each quarter, maybe we would want to find out like the average of like what our average is for each quarter, and we might want to make that another column itself. So that's actually what I wrote down over here. So you notice there is no average column already. If you actually just write your DF variable, and then you just write a column and put it in brackets, or you just put a string and put it in brackets right here, it'll automatically make this into its own column, even though it doesn't exist already. And then you just include what you want to include as the value. So this will be the new existing column, and then all this will be the values that it takes place within the different instances. So in here, I took the first, I'm taking DF first, so this entire first column, DF second, the entire second column, and the third column, and then the fourth column, and I'm just finding the sum of all of it. So I'm doing plus, 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 finding the sum of all these 4, and then I'm going to divide it by 4, and I'm going to divide it using floor division so that we end up getting a integer as opposed to a floating point number. And when I divide it by 4, that's just going to help me find out the average like I have up here. If I hit Shift Enter, now you can see we have a new column with our averages in there. And as you can see, since we use floor division, that they're integers as opposed to floating points. So that was just a quick example. I didn't want to make this video too long. It's already past 20 minutes, which was way longer than I wanted to show you. So hope this wasn't too daunting, but I definitely wanted to show you some examples, get you more familiar with it, but mainly have you guys practice this on your own. And also at the end, I really wanted to show you an example of how you guys are going to actually be using this in in a real life example. Okay, so with that being said, I hope you guys have a good rest of the day, and I will see you in the next video. Bye bye.